We're going to continue solving systems of linear equations. We did this last week, but we solved them by graphing. So just to review, what we did was we graphed both lines. This is a system. There's two equations that go together. We're going to graph both lines. Start at -4. My slope is an imaginary 1, so rise 1, run 1. And we're going to graph a line, not just a couple of points. So we're going to graph that line. Then we're going to graph this line. This is my blue line, this is my pink line. We're going to start at 2, up 1 over 7. Down 1, just to get some accuracy here. Now, do you see these lines? Unless they're parallel, they're going to cross. So some of you, because you couldn't find the cross point, wrote no solution. They only have no solution when they're parallel. These crossed. We see that they crossed at 7, 3. That is my solution. I solved it. I found the point that both lines have in common. They crossed there. They both have the point 7, 3 in common. But it's not always easy or conducive to solve these by graphing. Sometimes we've got really big numbers that wouldn't fit on the graph. Sometimes they're going to cross at not a perfect point, like a decimal or a fraction. Well, how do you know exactly where they crossed? If you're graphing it, you don't. So we need other ways to solve them besides graphing. Today we're going to learn to solve them by substitution. We know how to substitute. That's not a new concept. You've substituted lots of times in math. So let's look at this. Y equals this. I'm going to make this one my blue. Y equals that. But y also equals that. If both things are equal to y, aren't they equal to each other? Let's say that I have $1. 25 cents times 4 is $1. So 4 quarters is $1. But also 10 dimes is $1. 10 dimes and 4 quarters both equal $1. So they're equal to each other. This is equal to y, this is equal to y. So they're equal to each other. They're the same thing. So let's make a new equation where I make them equal to each other. If they're both equal to y, guys, I can substitute this for y and make them equal to each other. Now I've got one variable. I can't solve when I have two variables, an x and a y. I can solve when I only have one. So that's the reason I set them equal to each other, was so that I could solve it. I can solve for x. So let's subtract 4x and get -7x. And then we're going to, let's see, sorry about that. My mask wanted to play. Subtract the 4 and divide by your -7. So what does x equal? 2. Now all I did was solve for x. I am not finished. I want to solve the system. The solution is the point where the lines cross. All right, I found x, but I need y. So I can substitute again into either equation. I don't care which one. I'm going to use this one. Doesn't matter which one. So 4x minus 10. But instead of x, I'm going to put 2. So 4 times 2 is 8. 8 minus 10 is -2. There's my point of intersection. That's my solution. That's my answer to -2. So let's do a different one. On this one, y is 3x minus 4. And then I have this second equation. So since y is isolated, y is by itself. I know what y is. Can't I write down my second equation? But instead of y, let's substitute what y equals. This is y, this is y. So I can substitute for y. Why would W-H-Y, would I do that? So that I can have one variable, because I can't solve when I have two, but I can solve with one. Now they're all x's. I can do this. 4x plus, let's distribute. This part is not new. We've done this all year. Now I get 13x minus 12 equals 1. I'm going to add the 12. I'm going to get 13x equals 13. Divide by your 13 and x equals 1. Once again, I am not finished. I only know the x. I've got to find y. Doesn't it look like this one would be very easy to substitute into and find y? Y equals 3 times x minus 4. 3 minus 4 is negative 1. There's my equation. Now, it doesn't matter which one we solve for first. We need to do what's easy and what makes sense. So let's look at this next one. This one, x is by itself, so wouldn't it make sense to substitute for x instead of y? It doesn't matter which one you do first. This one makes more sense. Do what makes sense. So instead of x, I'm going to drop in the y plus 4. I'm substituting. Now I'm solving for y. This time I have everything in y. Let's distribute. Now I have an equation with all y's, so let's solve negative 10y because we combine our like terms. Then let's go ahead and I'm going to save some time and add the 16. Look, goes away. I know a lot of you still get confused when that happens, but it's 0. Negative 16, positive 16, they cancel, 0. Divide by negative 10 and 0 divided by anything is still 0. All right, this time be very careful. This is y. You solved for y this time. Now I need to substitute and find x. Well, which sure makes sense to do this first one. X equals y plus 4, but y is 0. So isn't x 4? There's your solution, 4, 0. So those are, I'm going to stop there. Those are just some examples of substitution. That's what we're doing today. We're solving by substitution instead of graphing.